Okay, we're going to use the square root property to solve quadratic equations. We'll start with the square root property, and then we'll talk about completing the square, and then try to identify when to use the square root property and when to use completing the square, and when they happen together. First thing says if we're going to take the square root, if we have x squared equal to some value k and we take the square root, we must remember that it could be positive or negative. That's important. Also, if k is less than 0, has no real solutions, there will be imaginary solutions that come up down the road. But we forget that when we take like the square root of, if I have x squared equals 9, then everybody understands that x is 3, but we have to remember that the answer is really plus or minus 3, because if you go back to the original problem, what number squared is equal to 9? Well, we square positive 3, we get 9. We square negative 3, we get 9. So we got to remember the plus or minus. Also, the positive is usually called the principal square root. A little bit more important, but we can't forget about the negative. So this one right here, it's as simple as plus or minus, and you get x is equal to plus or minus positive or negative square root 10. That's the exact value. If you want the decimal equivalent, please make sure that you're answering your question properly, because it would be an approximation. Oftentimes when we want exact form, we want it in simplified square root, but if we wanted to round it, say, to 2 places, maybe 3.16, which our calculator does for us. Next, we got this guy here. We can add 16. 25x squared equals 16. X squared is 16 over 25. Square root of a fraction, take the square root of the top separately from the square root of the bottom when they're perfect squares like this, and we get plus or minus 4/5. And we're good. This is one that we'll be working with. We're going to have square root, plus or minus. So I have x minus 3 is equal to plus or minus 4. Now I have to write it into 2 equations. X minus 3 equals 4. X minus 3 equals negative 4. Add 3, solve them separately. X is 7. Or add 3, x is negative 1. So we get 2 answers. X is 7 or x is negative 1. Go back up in the original equation. 7 minus 3 is 4. 4 squared is 16. Negative 1 minus 3 is negative 4. Negative 4 squared is 16. So we see that it works with both of them. If an object is dropped from the height of h feet, its distance d above the ground after t seconds is given by that equation. It says a toy falls 40 feet from a window. How long does it take the toy to hit the ground? So this is going to be h. So I'm going to have distance at time t will be equal to 40 minus 16t squared. If I'm hitting the ground, my height is 0. So I'm going to have 0 equals 40 minus 16t squared. Subtract 40. Divide by negative 16. I think in a time situation, we are probably looking, because 40 over 16 must be about, like 3.5, 2.5. So in this case, we're looking at 5 over 2 or 2.5. And now we're looking at taking the square root. Now, this is a case where, yeah, it should be plus or minus the square root of 2.5, but are we really going to worry about the negative time. So this is a case where the principal square root is going to be the correct answer because it's a word problem. Negative time does nothing for us, and I get 1.58 seconds for your iPhone to burst into 1,000 pieces from a 40-foot high window. Don't drop it. Okay, when we square x plus 5, if you were to square x plus 5, remember, what does it mean? X plus 5, I'm going to do it up here. X plus 5 times x plus 5 is x squared plus 5x plus 5x plus 25. Remember, we're doing foiling. I get 5x, 5x, boom, boom. I get x squared plus 10x plus 25. If I do x plus 4 and x plus 4, notice what's going to happen each time. X times x is x squared. I get plus 4x and then plus another 4x plus 16. So I end up with, up here I had two 5x's. Here I got two 4x's. It's going to happen every time we square a binomial. Whoops, there was two of them. So it's 4x and 4x is 8x. Down here, I'm going to make a prediction. I get x squared, and then I multiply those two terms together, get minus 3x. I think there's going to be two of them, though. Two of them. I think it's going to be minus 6x plus 9. Let's check it out, shall we? X minus 3 and x minus 3. X squared minus 3x minus 3x plus 9. I got it right. Now, examine these three things. Notice each time, where does the x squared come from? It comes from x times x, and it comes from squaring the first term. Where does the 25 come from? Came from 5 times 5, 16 came from 4 times 4. Where did the plus 9 come? Negative 3 times negative 3. So each time, the key thing here is what is the relationship between b and c? This is going to be this number times this number, which is 5x doubled. There's two of them, two 5x's. This one is this number, and there's two of them, two 4x's. And this one is two negative 3x's. So each time we are squaring a binomial, we need first term squared goes out front, last term squared goes in the back, and then we can multiply the two terms together and double it, multiply it by 2. That said, I will make a prediction that if we had x plus 7 squared, square the first term, square the last term, multiply them together, 7x, double it, 14x. And there you go. That is the case. Try it by foiling it out. What happens with a minus? X minus, let's do 9er. Square the first term, square the last term, multiply them together, minus 9, double it, minus 18x. Every time, this one, there's a relationship. Here we go, general form. I like to go, I don't like to go this direction. I like to go down with this. I'm going to go down here. I'm going to say I'm going to make this into a squared. The general form, notice x squared has a coefficient of 1. Now, to go from here to here, from the trinomial back to the binomial, what did we do? I'm going from 14 to 7, negative 18 to 9er. I go from 10 to 5, 8 to 4, negative 6 to 3. What are we doing each time? We are going and we're taking it and dividing it by 2. And then I take that value that was divided by 2 and I square it. I went down instead of across. Forgive me. So we're taking and we're dividing by 2, and then we square it. That's what makes me a perfect square. So when we go over here, find the value of c, and I also want to make this. X squared goes there. Divide this by 2, -6. Square it, plus 36. Think about that. X squared, -6 squared. Multiply them together and double it. Boom. We're just going the opposite direction. Over here, let's make this r, divide by 2. We divide by 2, -4. We are making a perfect square. This is called completing the square. And now we square it, and we get plus 16. Next one, we're going to actually solve. We're going to complete the square to solve. The first thing we have to do is isolate the x terms. That means get the x terms by themselves. Okay? So I'm going to go -5, -5. I'm going to get x squared plus 6x. Leave a blank. Equals 12 minus 5 is 7. Next, make a perfect square. X plus, what goes here? 6 divided by 2, 3. Squared, 9er. Here's a big moment. Pay attention. If I add 9 here, I gotta add 9 over here. I just added 9 to the left side of an equation. I must add 9 to the right side of an equation. So this is going to be equal to 16. Well, isn't this a problem that we've already kind of done? Very similar to it. Take the square root. Take the square root. Don't forget a plus or minus. X plus 3 is plus or minus 4. Solve 2 separate equations. And I subtract 3, subtract 3. X is 1. Subtract 3, subtract 3. X is -7. There's my 2 answers. And we're rolling. Now, the one on the left and the one on the right are 2 different problems. The one on the left is ready to solve. Okay? This is already a perfect square. You want to recognize 25, and you want to recognize that this is 2 5s. So you want to recognize this, and there's a whole section of problems that will be separated like this. X squared, multiply them together and double it, 5 squared equals 50. Now when I take the square root, now plus or minus, x plus 5 is plus or minus, and this is where we need to break down the square root of 50. Remember how you simplify the square root of 50 into the square root of 25 times the square root of 2. It's 5 square root of 2 plus or minus 5 square root of 2. Subtract 5 from both sides. Remember, exact form, if they're asking you for exact form, this is the answer. Can I add -5 with 5 square root of 2? I cannot. I can only add square roots with square roots. Whole numbers with whole numbers. So you want to recognize this as using the square root property. We make it into a perfect square, we do the problem. This one, this is not a perfect square. And if I added 22 over, it would not be a perfect square. So I want to subtract 6 from both sides. X squared minus 10x blank equals -28. Now I'm going to make a perfect square. I'm going to change colors. Again, x, what goes here? Cut that in half, -5. Now I got to square it, plus 25. Whatever I add to one side, I got to add the same thing to the other side. And I get -3. So let's look what we did here. I got the x terms by themselves, and now I completed the square. Remember, this is -10 divided by 2. Square root, plus or minus. X minus 5 equals plus or minus, square root of a negative. How do we deal with the square root of a negative? It's going to be an imaginary. So I have an I, and a square root 3. Remember, the i's come before square roots, they come after whole numbers. And now I will have two imaginary roots. I have no real root. X equals 5 plus or minus I root 3. And we're doing great. We're doing great. Okay, that's it. You're going to have problems like this one over here, which they're going to ask you to use the square root property to solve, where it's already set up in a nice perfect trinomial square. One step, solve. This one, you got to complete the square to solve. Got it? Good. Have a great day.